Second is we are controlling electrical power. So we are controlling electrical power using electronics. Then the third is, of course, the control. So you can see that. Hello, I'm Ramesh Origanti. This is a series of planned videos on the topic of power electronics, or the area of power electronics. They are meant for third and fourth year electrical engineering students. So they are at a basic level, if you will, understanding power electronics. That is the title of the series of talks. I hope the students will, or I hope you will find it useful. I hope practicing engineers who would like to revise some of the topics or understand or go through some of the topics once again will find these videos useful. There will be several videos. The first topic to be covered is, of course, the introduction to power electronics. And in this introduction itself, there will be a few videos. And the very first video is this. This is what is power electronics, obviously. That is the first video. So in this video, we will see what power electronics is, from a basic point of view, how it differs from signal electronics, and also what will constitute a simple power electronic system, and also how different areas come together to make this field of power electronics. So it is multidisciplinary. We will see that it is truly so. Okay, that will be the things covered in this video. So let's get started. We all are aware, or many of us are aware, of microelectronics. Microelectronics, or here I have called it as signal electronics. It is everywhere, from your cell phone to computers. So many gadgets these days, or all gadgets and systems use microelectronics or signal electronics. So what is their characteristics? Their main characteristics, if you can simplify and say, is that they process information or signals. They process information. For example, the microphone records whatever I'm speaking, converts my speech into an electrical signal, a current or voltage waveform which mimics the sound pressure waveform that I produce while speaking. So that is an analog signal. So I can amplify it, change it using analog electronics. Or I can use an analog to digital converter, and which is a microelectronic circuit, and convert it into a digital signal and process it using digital computers and so on. So digital signal also, digital information also in most cases is coded in the form of an electrical signal, a current or voltage waveform which contains the digital information. So that is the characteristics of signal electronics or microelectronics. They process information. You can amplify, you can change, you can compute, you can do so many things. Power electronics, on the other hand, processes electrical energy or electrical power. So while signal electronics or microelectronics processes information, power electronics processes electrical power. So that is the main characteristics. It is electronics. It processes power using electronics. While processing power, a power electronic system may be using signal electronics in order to determine what the output voltage has to be, or what the output power has to be, and for so many other purposes. So a power electronic system will also contain some microelectronic circuits most of the time. But the main business of a power electronic system or a power electronic circuit is the processing of electrical power. We will see now what we mean by processing of electrical power. Suppose you have a load. So what's a load? Load is anything that takes power. For example, if you have your mobile phone or cell phone, and it takes power, electrical power from the cell phone battery, so the rest of the cell phone is a load for the cell phone battery. The cell phone battery draws power from the mobile charger in order to get charged. So the cell phone battery itself becomes a load for the mobile charger. So you can see that something that acts as a source once can act as a load. Your microwave oven, refrigerator, your lamps in your house, all of them are loads for the AC mains. The electric car is a load for the batteries in the car. So load is anything that draws power. So I'm representing the load here by a box. Let us say the load is some circuit that you built, and that load requires 5 volts DC. And let us also say that we have an electrical source, and that source in this case is a battery. It could be AC mains, as we saw. Anything that can give electrical power to your load is the source. And let us say that this battery is a 24 volts battery. So you have power that you need, and you have the load that requires power, but the load requires power at 5 volts in this case, and the source can only give power at or around 24 volts. There is a mismatch. Power electronics is the area that, in one sense, that addresses this mismatch. It gives power to the load. It takes the power from the source, converts it into a form suitable for the load, and gives it. So it comes in between the source and the load. Now here you see that in this particular case, it's not simple, as you will see that there's a lot of circuits that will address just this problem. You can reduce the voltage 24 volts to 5 volts by adding a series resistor. That series resistor will drop the voltage, in this case the difference between 24 volts and 5 volts, that is 19 volts. It can drop across it so that the 5 volts appears across the load, and the load draws in effect power at 5 volts. That is lossy in the sense that involves a lot of power loss in the series resistor, and that is why such approaches, those are called linear approaches. We'll see why and all that. Linear approaches, we will see it in another video. Such approaches are not taken. We want the system, we want the power electronic system to be efficient. We are dealing with power here. So we would like the power efficiency to be maintained. We want to convert that power, the input power, into a form suitable for the load, but in an efficient manner. All right. Now, in order to make the power converter do its job, to make sure that it gives the voltage 5 volts, it develops 5 volts, you need certain additional circuit. These circuits are typically microelectronics based circuits. These are, you can call it as auxiliary circuits. This is what I mentioned a bit earlier, that power converter may be processing power, but you need additional signal electronic circuits. So this is done by a controller. Remember, the power converter is an electronic circuit. After all, this is power electronics, so we are doing everything through electronics. The power converter, though it is handling power, it's an electronic circuit. So the power converter is an electronic circuit, and we need to make sure that it operates properly by giving some signals to it. That's what this controller does. The controller has two functions. One is to ensure that the basic operation of the converter is taken care of. The switches, the power semiconductor devices, they are operated as switches. The power semiconductor devices are switched on and off properly, and that is the controller's business. In addition, while doing, it has to make sure that the overall function of the power electronic system is fulfilled. For example, in this case, we want to maintain the voltage at 5 volts. Even if the input voltage varies, the battery voltage may not be always strictly at 24 volts. When battery is discharged, the voltage may go down. So even when the system changes in that manner, the load can change. The load may be drawing 20 watts and then it can change to 5 watts due to some operation of the load. So the load current changes, the source voltage changes, but we still want the voltage at the terminal of the load to be maintained at 5 volts. So for that you need an additional control function to be implemented. That is also done by the controller. So this is the overall system level functionality. So controller does two functions. One is to ensure the basic operation of the converter, and another is to ensure that the overall aims and goals of the system is achieved. The power converter and the controller put together usually in many cases will be the power electronic system, that will be the power electronic equipment, if you will. You can see from here that we can come up with a simple definition for power electronics. You can see that the power electronics consists of three components, three areas, three sub-areas. One is we are doing everything using electronics. Second is we are controlling electrical power. So we are controlling electrical power using electronics. Then the third is, of course, the control. So you can see that this gives you a simple definition. It is a control of electrical power using electronics. Having said this, if you there are some power electronic circuits, such as, for example, power rectifiers, which uses just diodes, so there is no control. But that is also, they also come in power electronics, and they are studied in power electronics. But that is an exception rather than the rule. So for a large majority of what we are doing, you can see that it is control of electrical power through electronics. So that can become our definition for power electronics, control of electrical power using electronics. You can see that this is a multidisciplinary field. Even though we will be mainly studying power converter circuits, those are the electronic circuits that does the power conversion. That's what our main focus will be, together with a few other topics such as the power semiconductor switches, how they operate, and so on. But in order to make the power electronic equipment or your circuit in the lab function, you need to have these three steps. You need to have some knowledge of electronics. You need to have some knowledge of the load, electrical load, which will be electrical power. You are dealing with electrical power. And the third thing is you need to have some idea of controls. So inherently, power electronic systems are multidisciplinary. Next, we'll see how multidisciplinary power electronic systems truly are. There are several areas, several topics that come together to make power electronics possible. Uh, the first among them, the foremost among them, is the power semiconductor circuits. These are the power converter circuits. These are the electronic circuits that process power that we talked about. This is the main thing. And in that power converter circuits, we have, as we have seen, power devices or power semiconductor devices. These are devices like transistors, diodes, etc., but designed to handle power, electrical power. So that is a key difference. They are not signal electronic or microelectronic devices. These devices are used in the power converter circuits. So a power electronic engineer definitely has to know about them also. You might notice that I have mentioned power ICs also. These are power integrated circuits. At low power end, the power device, power semiconductor device, and the auxiliary circuits, or a large part of the auxiliary circuit, or can be put together to form a single IC in order to save space. For example, in a low power charger, you might find an integrated circuit. So some other power electronic engineers will be interested in that particular device and its applications and so on. Next, you may notice passive devices and materials. All power electronic circuits, or most of them, will be using capacitors, inductors, and some of them will be using transformers also. These passive components are designed or chosen especially for power converter applications to handle the voltage, the current, the power, frequency, etc. The materials used in them, the power electronics engineer has to be knowledgeable about them. The materials such as the magnetic materials, core materials, the dielectric materials used in the capacitors, power electronics engineer will typically be knowledgeable about them also. So that passive devices and materials become important for a power electronics engineer. I've mentioned electromagnetics here, that is magnetic design we are talking about. For example, the inductors and the transformers, they are typically not bought out. In many cases, the power electronic engineer will be designing from scratch those components, inductors and transformers, for power electronic applications. So understanding that is very important to a power electronics engineer. The next topic you might notice, I've mentioned electronic thermal packaging. You might wonder that should be, we have a mechanical engineer's job. Many times mechanical engineers do handle such packaging, but a power electronics engineer has to be aware of this packaging, of the packaging issues also. Sometimes a power electronics engineer might be asked to do the packaging. We are dealing with power. However efficient we make the power electronic circuit converter to be, still the converter will be dissipating power, wasting power. This power has to be taken out, extracted out of the unit and sent away. Otherwise, it will heat up the unit itself, the equipment itself, and everything inside it. So the devices can fail, will probably fail if you don't do it properly. So electronic thermal packaging is a critical aspect of power electronic design. The next I have mentioned electromagnetic compatibility. Power electronic converters, as I mentioned earlier, uses power semiconductor devices like transistors. They are used in switching mode. They are turned on or off like a switch. So So there is a large swing of currents and voltages inside the equipment in various parts of the equipment because of the switches. The switch turns on, switch turns off, so the current flows, current is blocked. This produces a lot of electromagnetic radiation, very often referred to as electromagnetic noise. And this electromagnetic radiation can interfere with equipment, electronic equipment, communication equipment, for example, outside the power electronic equipment. It can also, the electromagnetic radiation can also interfere with the power electronic equipment and its auxiliary electronics itself. So it is important to keep this electromagnetic radiation within limits. There are standards that have to be followed which imposes limits on the amount of radiation that this equipment, such that all power electronic equipment can generate, and they must be strictly followed, and power electronic engineers' design should be in such a manner as to keep this radiation low. So how to measure the radiation, how to keep the radiation, how to design in such a way that the electromagnetic compatibility is achieved becomes an important aspect of power electronic design. You can notice already that there is a variety of areas that come in to make a power electronic equipment. This is true of many other areas of engineering. We are particularly talking about power electronics design and power electronics equipment here. So the more a power electronics engineer knows, the better engineer he or she will be. Even though in this course we will be focusing mainly on the power converter circuits and a few of the other topics that are relevant to that immediately for our purpose. These topics are not in any particular order. So the next topic is in control systems. We already saw that the power electronics equipment is always placed inside a control system, inside a system to achieve some end, maintaining a voltage, maintaining a speed, whatever. So understanding control system is important to a power electronics engineer. Next I have mentioned applications. Power electronics is always designed for an application. It is applied in various areas, from a battery charger to a steel mill, steel cold rolling mill. Everywhere you will find that power electronics is applied. You have power system applications which will go into megawatts. You have transport applications like an electric car, electric train. You have computer applications, battery chargers, power supplies for computers, server power supplies. There are literally hundreds and thousands of applications, if not more. The technology can be different. The same converter, the same topology means the circuit structure. The same circuit, when it is used in a milliwatt converter or in a megawatt converter, you can expect the technology to be different. So the technology will definitely be different. So applications are very important for power electronics engineer, and power electronics design will generally be keeping the application in mind. Next is analog and digital electronics. As we saw, the controllers and the auxiliary circuits are all designed using analog and digital electronics. So that will be something that power electronic engineers will find useful to know. The next topic I have given is digital signal processing. In many cases, when the control is quite complicated and the system is quite elaborate, digital signal processors will come in handy in implementing the complex control systems, control schemes. For example, if you take a wind generator, and then let's say the wind generator has to be connected to the power grid, in between the wind generator and the power grid, you will have a power electronic processor, power converters, a few power converters put together. They will be there in between the wind generator and the power grid. And as you can expect, this control can be quite sophisticated, and very often they'll be implemented using digital signal processing. The next topic I've given is analog VLSI. As we all know, analog systems are out, digital systems are everywhere. High frequency power converters are one of the few places where analog VLSIs may still be found. So these VLSIs, that is very large scale integrated circuits, can be useful in controlling, in operating high frequency, medium or low power converters. The last item that I have given is computer-aided design. Everywhere the design environment nowadays is based on CAD environment, that is a computer-aided design environment. Power electronics designs is no exception. So you can see that I have given a list of areas that help or that are necessary for power electronics. In the power electronics course, we will be mostly focusing on the power converter circuits. But if you are keen on keeping power electronics as an option or pursuing it, then the more stuff you know, the more comfortable, the better power electronics engineer you will be. The more you will know about power devices or electromagnetic compatibility or control systems or digital signal processing, they will all help you. So you can see that power electronics is truly multidisciplinary. And when you buy a charger or a computer power supply, many of these aspects have been taken care of in producing that by the engineers working on it. If you find this video interesting and useful, please do consider subscribing to this channel. Thank you.